Hello everyone, welcome to this video. We are going to talk about X-ray imaging system. So, what is the label part in X-ray tube? This is the picture of X-ray tube with its label part. The first label is power supply bulb. Bulb lights up when power on. The second label is angulation display. It displays tube rotation angle. The third label is vertical lock release button. It releases magnetic lock to allow vertical tube motion. The fourth label part is O lock release button. It releases O OTS magnetic lock to allow vertical, transverse, longitudinal, and tube angulation motions. The fifth label is vertical field of view adjustment. It adjusts the length of field of view. The sixth label is power FOV button. It switches on and off of FOV power. The seventh label is the horizontal FOV adjustment. It adjusts the width of field of view. The eighth label is the angle rotation button. It rotates the X-ray tube in a range of 0 to 90 degrees. The last label is horizontal button. It moves X-ray tube in left and right motion. Now, let us continue with the control panel. This is the image of control panel with its label part. The first label is the kV indicator. It displays exposure of kV. The second label is MAS indicator. It displays exposure of MAS. The third label is MA indicator. It displays exposure of MA. The fourth label is the MS indicator. It displays exposure of MS. The fifth label is the dipman button. It is used to start the exposure of X-ray. The sixth label is kV increment and decrement keys. It increases or decreases exposure kV between the value of 40 to 150. The seventh label is MA and MAS increment and decrement keys. It increases or decreases exposure of MA and MAS. The eighth label is MS increment and decrement keys. It increases or decreases exposure of MS. The ninth label is receptor. It selects tabletop, table bucky, wall stand foam cabinet or tourmaline as the image receptor. The 10th label is the focal spot selection. It controls the source of X-ray, bulb, or small focal spot. The 11th label is body anatomy. It selects the part to be exposed. The 12th label is PREP. It prepares for exposure. The 13th label is the exposure button. It completes the exposure. The 14th label is the exposure view. It chooses the view for exposure. The 15th label is the AEC. It chooses the intensity of the exposure part. The 16th label is the body type button. It chooses the exposure by using the parameters suggested for different body size of patient. The last label is the power. It switches on and off of the control panel. Now we are going to talk about the transformers. Transformer is the principal component of X-ray generators. There are three types of transformers, which are step-up transformer, isolation transformer, and step-down transformer. Let's begin with step-up transformer. It increases voltage because the number of secondary winding is more than the number of primary winding. For the isolation transformer, it isolates voltage because the number of primary winding is same with the number of secondary winding. For the step-down transformer, it decreases voltage because the number of primary winding is more than the number of secondary winding. Now, let's move to the diodes. Diodes having two terminals. It allows electrons to flow from cathode to anode in one direction. For triodes, it has 3 terminals. It is used as an amplifier for both audio and radio signals or as an oscillator in electronic circuits. For tetrodes, it has 4 terminals. It is used in power amplification.
Now I'm gonna talk about single phase. Single phase generator use a single phase power supply. Single phase generator use a bridge rectifier circuit that direct the alternating flow of high voltage electron so that flow is always from cathode to anode. Single phase generators are common for dental radiography where teeth are relatively thin and longer exposure time are tolerable. Single phase can be divided into two, which are half-wave rectification and full-wave rectification. Half-wave rectification use solid-state diode to effectively suppress the negative portion of the AC sine wave. The positive portion of the sine wave is utilized to produce pulsing DC. Full-wave rectified circuit because the negative part of the AC sine wave is converted to positive current. With full-wave rectification, the positive flow remains the same but the negative portion is converted to positive current flowing in only one direction. This produces more uniform pulsing DC sine wave. There are two disadvantages of single phase. First is intensity only significant when voltage is near peak. Second is low voltage hit target and produce low energy photon, where absorbed in tube, filter or patient can be contribute to those.
Three-phase generator use a three-phase alternating current line sources, full-wave rectified waveform produced by high-voltage circuit, and contain 3 auto transformers and 3 windings on both primary and secondary coil. When 3 windings are electrically connected in Y configuration, 120 phase difference in the voltage waveform is produced, and when the 3 windings are arranged in the delta configuration, 150 phase difference in the voltage waveform is produced. 3-phase 6-box generator use 6 rectifiers in their secondary coil and resulting waveform consists of 6 pulses per cycle, 360 pulses per second. This figure shows 6 rectifier is used in this generator. 3-phase 12-box generator use 12 rectifiers in their secondary coil and resulting waveform consists of 12 pulses per cycle, 720 pulses per second. The higher the pulse, the higher the efficiency of our unit. This generator allows faster exposure that will reducing patient dose. This figure shows 12 rectifier is used in this generator. This table shows the differences between single phase and 3-phase. High frequency generator, common use for all X-ray equipment from mobile, conventional, fluoroscopy, DSA and CT scan. Use 500 pulses per second and produce a multi-pulse wave with low ripple and less patient exposure. Constant potential generator produce a true direct current variation on 3-phase 12-pulse circuit. Use solid-state field effect transistor to produce a ripple-free direct current output. Fast exposure time, allow rate of 500 pulses per second or more.
Okay, now let's move to the type of circuit. Today we're going to discuss about primary circuit. Primary circuit is the main circuit that modifies incoming current to produce X-rays and boosts voltage to range that necessary for producing the X-rays. And it also modifies incoming line power to produce thermal emission from the filament wire. Primary circuit consists of autotransformers and line voltage compensator.
What is autotransformer? It is a one-winding transformer which its output voltage is proportional to the number of coils between the tap secondary, and its function to supply the voltage for secondary and filament circuit.
What does line voltage compensator do? It monitors input of line voltage. It also adjusts for drops or surge in line voltage, and it also compensates for fluctuation. The line voltage compensator affects the quality of X-ray beam, and it can be controlled automatic or manual. The other types of circuit is filament circuit. Filament circuit supplies the X-ray tube filament with the voltage needed to provide the desired tube current. Filament circuits also have a step-down transformer, which is the filament transformer. It supplies the power to heat the tube filament, which is connected directly to the secondary coil of the transformer. The step-down transformer converts primary voltage, which is 110 to 220 volt, to the potential difference required by the tube filament, which is approximately 10 volt. Due to the small change in filament current leads to a large change in tube current, the filament voltage must be precisely controlled. Therefore, the resistors are placed near to the auto transformers, and only selectable resistance is controlled by a switch on the control panel.
And now we are moving to the last part of X-ray imaging system, which is the secondary circuit. Secondary circuit, which also called as step-up transformers or catenary circuit, is a device that functions to increase the voltage. It is located at the step-up side of the transformers and has more turn of the coil compared to the primary circuit. Secondary circuit consists of kVp meter, mA meter, and rectifier. Milliamperage is a major factor in determining the quantity of X-rays produced, and therefore a good indication of the type of examination that can be performed with a machine. mA meter, which is connected to the secondary coil of the step-up transformers, functions to monitor the X-ray tube current. And now moving on to the kVp meter. kVp meter is usually located between the auto transformer and the step-up transformer. When a particular kVp is selected, the pair of secondary taps will give information to primary circuit based on the kVp selected. In the X-ray tube, for the electron to flow from cathode to anode, we can't use alternating current, or the current will flow back and forth from anode to cathode and it will damage the tube. That's why we need one direct current, but the current we receive from high voltage transformer is still in AC form. So, before entering the X-ray tube, a rectifier will be used. Rectifier, which consists of diodes, will change AC output from high voltage transformer to a DC so that current flow only in one direction. As I explained before, there are two types of rectification, which are the half-wave rectification and full-wave rectification. That's all for X-ray imaging system. Thanks for watching.